Previously, I finished the function of getting the password from the user for further encryption and decryption. This time, I would like to build the encryption function using the password obtained. You can go to my GitHub page for the code, link in the description. In order to encrypt the message, I would like to create an unsigned character pointer for the encrypted message and a number for its length. Create the encryption function, then assign the return pointer to the encrypted message pointer. Inside the function, I need to first initialize the Sodium library for the password hashing and the encryption algorithm. Next, I create a 32 bytes key array to store the hashed key from Argon 2 for further encryption. To hash the password to a 32 bytes key, it requires a salt, which should be a random value for security reasons. Thus, here I create a 16-byte salt array, then generate and assign a random value to it. Next, I can hash the password to the key array. Now that I have the hashed key, I would like to encrypt the message. Here I create another array for the ciphertext, which includes the message and the 16-byte authentication tag, and a number for the ciphertext's length. Then to make sure each encryption is different, I create one final random array called nonce, which occupies 12 bytes. Finally, encrypt the message to the ciphertext with all these information. However, this is not the end. The next step is to package all the necessary information for the receiver to decrypt. Here I allocate just enough memory for this task and have an encrypted message pointer pointing to this chunk of memory. The first one is a type converter ciphertext's length with 8 bytes. The second one is the salt with 16 bytes. The third one is the nonce with 12 bytes. The final one is the ciphertext with its length. After returning the encrypted message pointer to the main function, the destination IP address, encrypted message, and the length for the encrypted message are passed to the runSender function. Then after sending the encrypted message through the runSender function, free the memory for the password and the encrypted message. Then that is the end of the program. If you would like to compile this program yourself, make sure you already downloaded the Sodium library first. Let's test it by sending some messages from my Arch Linux system to my Kali Linux system. As you can see that only few can actually print out a character. This is because after the encryption, the information being sent is in binary, which most of them don't have a corresponding printable character, plus quite a lot of them are related to the null terminator, which force the process of printing a character string stop. In the next video, I'll finish the final part of the program, namely the decryption function, then test the program. Although I said in the past that this CLI tool for PC-to-PC messaging is just a side quest for my bigger project, the secure telemetry system for a model UAV, it seems that right now I'm more interested in working on cryptography and the mathematics behind. So I'll switch my focus from embedded security systems to theories and coding about cryptography, and see what I'll learn along the way. I know my videos might not be very entertaining for now. I'll keep improving the way I present ideas, whether it's about mathematics, coding, or my personal philosophical ideas. Thank you for your support, and see you in the next one.